Now that we are ready to proceed, the first conic section we're going to talk about is parabolas. We've spent the most time looking at those this year. That was all of Chapter 4. And we've seen them again since, but briefly. So these are both parabolas. In Chapter 9, we will see the parabola we've seen before, that is the upright parabola. In this case, though, when we're analyzing it in Chapter 9, we're not going to solve it for y, which would be y equals something times x squared. That's the way we're used to seeing it. When we study parabolas in this section, we're going to solve for the squared number. So x squared equals 4py. That's an upright parabola. Now you can still recognize it because the y is not squared, but the x is, because you know y equals x squared goes up or down. Its sideways companion here, the y is squared and the x is not. It's the one that goes to one side or the other. The way the formula is written has to do with the geometry of the situation, which I will explain in just a second. But note that p is a constant. It's a number. When we see an example of this, it's actually going to look something more like y squared equals 20x. That would be an actual equation for a parabola rather than just the standard form. And part of the trick in interpreting a parabola equation is to understand that this number 20 is actually 4 times p. So figuring out what p is going to be your first step in solving the problem. In this example, p is 5. That'll be the first example we graph. But I will come back to that. So when you're looking at this, the geometry of the situation, technically parabolas, as we've been graphing them, have a very precise definition in geometry, and it goes like this. A parabola is the set of all points that are the same distance from some point called the focus and some line called the directrix. This line right here that's not part of the parabola is called the focus. It's kind of like the center of a circle, where it's not actually part of the circle, but the definition of a circle relies heavily on its center. This is the focus for the parabola. This here is called the directrix. It's the line. Now any point on the parabola, I drew this one because it was easy for me. This point is 4 spaces away from the focus and also 4 spaces away from the directrix. That's why it's on the parabola. The vertex is the midpoint between the focus and the directrix, so it is also the same distance from the focus and directrix. This point over here, 4 away from each. All the points in the middle are also equidistant. This one's a little more than 2.5, it looks like. And if you drew the straight line here and were able to measure it, it's also a little bit more than 2 squares. When we're graphing them, we try to find the nice easy ones so that we don't have to spend a lot of time using square roots. So when you graph this, you're going to find the midpoint, the vertex, which is the midpoint between the focus and the directrix. And then you're going to go parallel to the directrix out to the sides to draw the easy points, and then draw your parabola. What we're actually responsible to be able to do this section, all of our parabolas are going to have vertex at 0, 0. So we're going to either get an equation and draw the graph, or we're going to, the book will describe the graph to you and expect you to be able to write the equation. You should be able to do it from the picture of a graph, and that will happen in later sections with the other shapes, but for today, they're not going to give you a graph ever and expect you to interpret it. They're going to give you the numbers for either the focus or the directrix. So let's get into the examples. I have, 3, 4, 5, 6, 7 examples of the 3 ways that this works out. So the first way is this. We have an equation and we're going to graph it. So the first step is to figure out what p is, because I need to figure out what got multiplied here. This 20 is 4p. Now, if you're ever confused, if you can't do it in your head here, I know 4 times 5 is 20. If it turns out it's going to be a decimal, or for some reason you're having trouble, you can make a little equation, take 4p, set it equal to whatever that number is, solve for p. In this case, divide by 4, I get 5. So p is 5. Now, one of the things this tells us, since p is positive, is that our focus is going to be higher than our vertex, because p is positive. Now, in this case, to the right, this is a sideways parabola. The y is the one that's squared. It's going to open to the right. So my vertex is going to be at 0, 0. That will always be true through most of this chapter. Right at the end of the chapter, we come back through and learn to graph them all if they've been moved around. But for now, the centers will all be at 0, 0. P is the distance from the vertex to the focus. So since this is a sideways parabola, P is positive, so I'm moving to the right. It's going to be at 5, 0. 5 spaces to the right. There's my focus. The directrix is going to be the opposite direction. 2, 3, 4, 5. Over here at negative 5. X equals negative 5. My vertex I've drawn. Now the distance from my... Oh, wow, this is going to be huge. I'm going to bail. I'm going to go by 2s. 2, 4, 5, which makes my directrix here. These are going to be very wide. It turns out the parabolas that we were drawing in Chapter 4 had focuses very close to their vertices. That's what makes them so skinny. The parabolas you're likely to see in this chapter are going to be a whole lot wider. So going by 2s may not be a bad idea for a number of these problems. Okay, so this distance is 5, this distance is 5. So the distance, if I go straight up, the distance across here is going to be 10. 5 to get to the axis and 5 more to get right above my focus here. So the distance from the line is going to be 10. So I need to go 10 spaces up. 2, 4, 6, 8, 10. This point right here then is 5, 10. And it's on my parabola because it's 10 to get from negative 5 to 5, and it's 10 to get from 0 to 10. Similarly, 2, 4, 6, 8, 10. This point here, 5, negative 10. And I draw my parabola going both ways. Y equals 20x. You'll want to label your directrix and your focus. And labeling a couple points is a good idea. Let's do another example. Also horizontal this time. But let's make this negative 12x. So if you think about it, what do you multiply by 4 to get negative 12? And the answer is negative 3. So in this case, P is negative 3. Now all of these are going to have their vertex at 0, 0. In this case, the focus is going to be to the left because P is negative 9. I'm going to go by 2s again to save space. So 3 is right here, negative 3, 0. The directrix will be over here at negative 3. X equals negative 3. Now the distance from my line to the line parallel to it that goes through the focus there is 6. So I need to go down 6 spaces and up 6 spaces. And here's my parabola. That's negative 3, 6, and negative 3, negative 6 on my parabola. Got one more of these, and then we'll move on to writing equations, which takes up a lot less space, actually. My last example of this, x squared equals 2y. So because the x is squared, this is a parabola that opens up or down, like the ones we've used to seeing. In this case, P is positive for sure, because this number is positive, so it is going to open up rather than down. But 4P has to equal 2, which means P is actually 2 divided by 4, or 1/2. So the focus is going to be very close to my vertex. My vertex is at 0, 0. My focus is at 0, 1/2. My vertex is at 0, 0. That means the directrix is at negative 1/2. It's kind of low. Y equals negative 1/2 is my directrix. So there's my focus. The distance from my directrix to my focus is 1, 1/2 plus 1/2. So my new points are this one and this one. 1, 1/2, and negative 1, negative 1, comma 1/2. Parabola, parabola. If you ever get confused, I like to think of the parabola hugging the focus. It's nice. It fills me with warm and fuzzies. So there's 3 graphs. You'll be graphing a fair bit, but we also want to be prepared to do this the other way around. That is to write the equation from a graph or from a description. Now all of them will have their vertex at 0, 0, but we can write a parabola as long as we're given a piece of information, the focus or the directrix, in addition to the vertex here. So if the focus is at 0, 8, and my vertex is at 0, 0, I can use that to find P. I won't draw the rest of them since it's unnecessary, but I will make a little sketch of this one just to get us thinking. So there's my axis, vertex at 0, 0. The focus is at 0, 8, that's up, which means my parabola is going to hug my focus like this. So this is an upright parabola. That means it's going to be x squared equals 4py for its equation. Now since the focus is at 0, 8 and the vertex 0, 0, the distance there is 8. It's up 8. So p is 8, and that means 4p is 4 times 8, which is 32. So x squared equals 32y. That's my parabola. Let's do another example where the focus is at 2, 0. Now if the focus is at 2, 0, that's to the right. Well, I'll draw it again. So my vertex is at 0, 0, my focus is at 2, 0. That's opening to the right, which means the y is what's squared. Y squared equals 4px. Because 2, 0 is 2 spaces away from 0, 0, p is 2. P equals 8. Alright, p is 2, which means what we're looking at here is y squared equals 4 times 2 is 8x. So as promised, these take much less room. Oh, if the focus were underneath or to the left, p would end up being negative. And that would be fine. You just have a negative number here. Now you could also do one of these where the directrix is given. So if my vertex is at 0, 0, and my directrix is, for example, x equals negative 5. Now x equals negative 5 is a vertical line over here. And my parabola is going to hug the focus away from my vertical line. So this is leaning on its side, which means the y is what's squared. Since the directrix is always opposite the focus, this is negative 5, which means my p is actually going to be positive 5, because the directrix is opposite. So positive 5. And that means this is y equals 20x. That's the first one we graphed. And then if the directrix were instead y equals 6, then p would be negative 6. But because y equals 6 is a horizontal line up here, this parabola opens down. P is negative 6, so it's x squared equals 4px. No, sorry, y. Yes, or x squared equals negative 24y. That's a little sloppy. X squared equals negative 24y. So we should be able to, from an equation, sketch a parabola, its focus and directrix. We should be able to, from a description of the focus and directrix, focus and vertex, or vertex and directrix, be able to find the equation. You should be able to do it from the focus and directrix as well, but I don't think your book is going to have you do that. So that should be what you need. Let me know if you get stuck. You can start on your problems now.